Hello, good morning, everyone. So I am your teacher, Kenneth Alvero, and I'll be your teacher for today. So, so who will be the prayer for today? Okay, Miss Irish Manel, can you please lead the prayer? Okay. Okay, thank you. But before we start our lesson, please clean the environment first and arrange the chairs and pick up some instructions. Okay, so I have here the classroom rules. First, listen attentively when the teacher or classmate are speaking. Second, raise your hand before answering or asking questions. Third, respect everyone, ideas and opinions. Fourth, follow instructions during activities and experiments. And lastly, keep your workspace clean and organized. Is it is it clear? Okay, thank you. So I have here a video presentation okay. Please observe and explain kung ano inyong nakita. So, kung ano na. O saan inyong nakita sa atong video presentation? Okay, Mr. Waay. Okay, thank you. So, our topic for today is, yes? Okay, you can. Okay, so our topic for today is all about thermodynamics, real gas, and change of phase. So, I have read objectives at the end of the lesson, so they should be able to describe real gases and their properties, appreciate the differences between real gases and ideal gases in relation to real-life application, explain different types of phase changes, and demonstrate simple home-based activities showing evaporation and condensation using available materials. So, what is real gas? Mr. Reggie, what? Mr. Reggie, I know. What? Mr. Reggie, what is real gas? Okay, thank you. So, a real gas is a gas that exists in the real world, whose particles have actual volume and experience intermolecular forces, causing its behavior to deviate from the ideal gas law, especially at high pressure and low temperature. So, examples of real gas: oxygen behave like a real gas, especially under high pressure. Nitrogen, commonly used in industry, shows real gas behavior at low temperature, and carbon dioxide deviates from ideal gas law, especially when compressed or cold. And last, ammonia has strong intermolecular forces, so it behaves as a real gas. And hydrogen, at very high pressure or low temperature, it does not act like an ideal gas. So, I have here the properties of real gas. First is have definition of volume. The gas particles occupy space. Experience intermolecular forces. Particles attract or repel each other. Deviate from ideal behavior. They do not always follow the ideal gas law or PV inerty, especially high pressure and low temperature. Compressible. Like all gases, their volume can change under pressure. Nakasabot ra ba ta?
Yes, ma'am.
Okay. And expand to fill containers. They spread out to occupy the available space. Molecules are in constant motion. Ang sama ibig sabihin sa constant motion? Sige sila, liho. So particles move randomly in all directions. So ang particles lang kung namumove sila sa direction. Okay. So, I have here si Johannes Diederik van der Waals. He is a Dutch physicist who famously studied the behavior of real gas and liquids. He developed the van der Waals equation, which adjusts the ideal gas law to account for volume of gas particles and intermolecular forces. So I have here the equations, the equation for van der Waals. For M is a moles of gas, and the equation is P plus A n squared. Ang n ang moles, tapos over volume squared, volume ni, times volume equals NV equal, minus the I. V minus NV equals to nRT. For 1 mole of gas using molar volume, Vm equals V over N. It is expressed as P plus A over V squared M times Vm minus V equals RT. So definition of variables: P is pressure, V is volume and number of moles, R is gas constant, T is temperature, and A, correction for intermolecular forces or attraction, B, correction for volume of particles. For example, suppose 1 mole of carbon dioxide is in 10-liter container at 300 Kelvin. The material constant for carbon dioxide are ang sa pang A, ang A mauna ang correction for intermolecular forces, and B is the correction for volume of gas particles, and R mauna na ang gas constant ni siya. So we want to find the pressure. So atong i-find ka ang pressure. Step 1, substitute the value. Imo daw kung i-substitute ang value. Kaya diyan naman, first you write the equation and then you write the value. For example, siya, ang value ano siya only 3.59 times 1 squared over 10 squared. And the response is what? Step 2 is simplify. Diba, imo na siya i-divide ni siya o imo sa siya i-minus. Mo na siya mas ini siya imo na siya sa ubos. And step 3, solve for P. O sa ang P? Ang P, mauna siya ang pressure. Mauna siya ang pressure. We have to solve the pressure. Tapos ini siya, imo ni siya divide. This is 24 consistent divided by 9.9 times 73 equals to 2.472. Amount siya, answer sinisino pag-divide. Tapos kini siya ini siya nga number, may butang sa diri para siya ma-minus. So 2.472 minus 0.0359 equals to 2.436 atmosphere. Second example, mauna dapat ang kanang equation sa to, where pressure is, iba na nga yun siya nga equation na po, pero same na sila ang process. Where P is pressure, Vm is molar volume or volume per mole, R is the constant, mauna siya ang constant. Constant na siya ang R. 0.0821 liter per atmosphere per mole per Kelvin. T is temperature. A, B is the van der Waals constant. Suppose 1 mole of carbon dioxide at 300 Kelvin has a molar volume equals 10 liter per mole. Real gases in real life show the actual behavior of gases imported at high pressure and low temperature. Using gas storage like LPG tanks, oxygen tanks, applied refrigeration and air conditioning systems. Important in industry, and it is important also in industrial processes and chemical reactions. So why this is important? Real gases. It helps to ensure accuracy in calculations, ensure safety when handling gases, improves efficiency in real-world applications. All gases are real gases, but they are more like ideal gas. Why? Because because of low temperature and because of low pressure and high temperature. So why real gas act as ideal gas? Ano man? So makapatan ka lang. Kaya thank you, Mr. Conjan. Okay. Real gases can act like ideal gas under certain conditions because the effects of particles, volume, and the thermal forces become negligible. So I have here the different types of phase changes. So phase changes na punta. First is melting or fusion solid to liquid. When a solid absorbs enough heat, its particles gain energy to overcome fixed position and start moving freely, turning into liquid. Examples, ice melting. Examples, mauna sa dyan, melting sa dyan example. Number 2, freezing or solidification, liquid to solid. When a liquid loses heat, its particles slow down and arrange to fixed positions, forming a solid. Examples, water turning into ice. Always remember ang process hindi kay heat to cold. Dili cold to heat. 3. Vaporization, evaporation, or the liquid gas. When a liquid absorbs heat, its particle gain enough energy to break away from the liquid surface. Evaporation or throughout the liquid boiling forming gas. Example, water boiling to produce steam. Mauna ang vaporization or evaporation or boiling. Condensation, gas to liquid. When a gas loses heat, its particles slow down and come closer together, forming a liquid. Mauna siya ang steam. Kung natay, ito pa malayo. Example, steam pouring into water droplets or on a cold surface. Like magkuhan ka, magpulo-pulo ka water, dry steam sa ijang lead, mauna siya ang condensation. And sublimation, solid to gas. Some solids can absorb enough energy to change their weight into gas without becoming liquid. Examples, dry ice or solid carbon dioxide turning into carbon dioxide gas. Example sa sublimation. And then deposition, gas or solid. A gas can lose energy quickly and change directly into a solid without first becoming a liquid. Examples is frost forming from water vapor on a cold morning. More an example. So I have it. So activity 5 na kata. Direction, demonstrate and record evaporation and condensation using simple home materials and explain what happens to the water particles. Materials yung gamitan tayo clear glass or cup, hot water from kettle or stove, supervise, ice cubes or small plates or leaves. See, the instruction, pour hot water into a clear glass liquid. Observe the steam rising. This is evaporation. Place a whole plate or lid above the glass and observe water droplets forming on the plate or lid. This is the condensation. And record your observation in simple table. So I have a table and draw a simple diagram showing evaporation and condensation. Write 2 to 3 sentences explaining what happens to the particles. So I have here the rubrics. Okay. Real gases are substances whose particles have actual volume and interact with each other, causing them to behave differently under certain conditions. They can undergo phase changes such as melting, freezing, evaporation, condensation, sublimation, and deposition, which involve the transfer of energy and changes in particles movement. Observing these changes helps us understand how gases behave in everyday life. This time, direction. We read each question carefully and choose the letter of the correct answer. So number one, which of the following gases is commonly used to show a real gas? Behavior at low temperature. Okay. Okay, moving on. Two, real gases differ from ideal gases. Different because they, okay, nabasa na. Okay, thank you. So here the answer key. Okay. Kasi naka-10. Okay, thank you. Sign for your assignment. Identify and explain examples of real gas behavior and phase changes in everyday situation. So please follow na lang sa instruction and present your examples here in the table format. I will give you the format of the table. And draw a small diagram for at least one example showing how the particles behave. And write total base synthesis for your reflection. And for your grading rubrics here, the grading rubrics. And that's all. Thank you for listening.